good evening or good night wherever you are. This tutorial is going to be very quick, so we're going to generate a land cover classification map using several datasets. Those datasets include the ALOS PALSAR mosaics, Sentinel-2 data, Sentinel-1 data, as well as Landsat-8. So first of all, we have here the top of the window here in the imports, we have a shapefile that defines our region of interest. This was uploaded using the assets and the tool here. When you go to asset and new, you can upload shapefiles and geotiff files. The same way we uploaded the shapefile, we also uploaded a geotiff file, actually 3 files that represent band 3, 4, 5 from Sentinel-2 images. So although Sentinel-2 is available in the Google Earth Engine catalog, I prefer to use the Sentinel Hub datasets because I found the cloud masking to be better. So I'm uploading the Sentinel-2 data from my desktop, so I generated the mosaics separately using Sentinel Hub and uploaded it here in my Google Earth Engine code. The other datasets, so ALOS, PALSAR, and Landsat-8, are included directly within my code. So here you have Landsat-8, and we have ALOS data a little bit further down. Okay, so we have 3 methods in this code to insert data. You don't have to do that. You could use the same method for almost all of them other than the shapefile, but here is just for demonstration purposes. So one of the first thing here is to center your image at the bottom here. In this frame you have your site, so it's centered at 58.5 west and 7.4 north with a zoom of 11. So the larger the zoom, the smaller is the area displayed in your window. So here I have what I call my GEE classes, which include mangroves, water, forest, wetlands, agriculture, and mudflats. So these I have defined earlier using this tool here at the bottom, which is really cool. So if you go into geometry import, you will see probably nothing in your case because you haven't defined anything yet. So what we're going to do at this point is define those classes. So let's do that. Let's define a new one. So let's put a new layer. Oh, first of all, let's look at the one that already exists. So red mangroves. I already defined them, so we define red mangroves, so the name of my class is as I spelled it out here. This is a feature collection because we'll have several points. Here, importantly in my code, I refer to this attribute which is called class_ID with a value of 7. Okay, so all my red mangrove points which I selected have class ID equal to 7. So let's define a new one. So here it's called initially geometry. So you can change the name. So let's call it example class. Geometry, let's do a feature collection. And you click OK. You can actually choose the color of, let's go for blue. Okay. So we already had a blue class, but that's okay. Well, let's just go on. So here you can either define your example class by clicking points. You can zoom in. I recommend not using the satellite background because you don't know what the date of the background is. So whatever your new class is, it may not be there anymore. It may have changed. So I recommend using one of the products that you uploaded to your code. So here I've already displayed my Sentinel-2 data. So this is the Sentinel-2 red, green, blue image, which is from 2017. So I'm trying to make a classification map for 2017. So I'm going to use this as a background to select my points. So okay, I'm just selecting some random points here. So you should select them attentively. I just wanted to show you that you can do either points, or you can also do polygons like this. So you can have more pixels in training your land cover classification algorithm. And to close that polygon, you have to do a right click, and for the Mac you have to push option click on the mouse. Okay, so now we have this new example class which has 7 points and 1 polygon, and you can lock it if you don't want to touch it again. So in our case, I think I'm just going to unlock it and actually erase it. So you erase it by going into that little wheel, and then that new window pops up. You can also change the name of your class, and you can delete it. Okay, so now it's out of it. It's out of my classes. I will delete this previous example that was left over from earlier work. Okay, so now I have my classes which are uploaded here, and they're available for classification. So all the points that I show in my window here at the bottom are available to the code, but they are all separate, right? So now what we want to do is to merge all those data points. Remember, the class underscore ID contains the class of each of these points. So even if you merge all these points, they still have the class ID. So I merge these into my GEE classes. So this is my training set, basically. So I merge mudflat to agriculture, to wetland, to forest, to water, to like mangroves, and I called it my GEE classes. So here you have a new variable called bands. So B2, B3, and so on, HV. This I will be using a little bit later. So those are the bands that I am expecting to use once I have collected all the remote sensing data products into a cube. So I just predefined it here, but this is just for now string. This is just for display purposes. So this is a new variable that I call S2 hub viz, and I will be using it for displaying my Sentinel-2 data with min of 10 and maximum to 30. So I had a look at the values earlier, so I know that. So basins, remember, I'm clipping to the basin. So basin is that shapefile that I uploaded from my desktop using the tab asset and clicking on new. I'm using that to clip all my data. So here I'm adding bands 4 and 5 to 3. So I'm just making a data cube here. And I just rename each of the layers within that cube SB3, B4, and B5. And I'm adding the layer to the display here. So this is how this shows up. So remember that viz here, so this is from 10 to 30. So this is what shows up here, Sentinel-2 mosaic hub. Next, we load the Landsat, Sentinel-1, and ALOS PALSAR data. So here I'm using top of the atmosphere Landsat-8 data, which I upload to my code. This is from the Google Earth Engine catalog. And I make a composite image. So basically I'm getting all the good pixels from January 1st through December 31st to generate a mosaic of 2017. So of course here I am not taking into account any phenology or changes, for example, in agricultural fields or everything. So everything that happened during that year will be smoothed out into a single image. And I clip to my region of interest. Now let's look at Sentinel-1. So I will try to retrieve the VH polarization. So you have VV and VH for Sentinel-1. I will again generate a mosaic. So in this case here, I'm taking data from the 1st of September through the 31st of October. So here I think this is the dry season for the region. So I'm using only a couple months of data. Remember here that radar data sees through clouds, so we don't have the problem of filtering out the clouds for radar. But there are changes in moisture and changes in the land cover during that period that will be smoothed out. For Landsat, this is more difficult. It's hard to find for coastal areas a cloud-free data set, so the period sometimes has to be much larger, like I did for Landsat-8, so a full year for Landsat-8 and just a couple of months for Sentinel-1. That also reduces the effect of land cover changes in that period. So if you don't have many clouds in your region, don't average or don't generate these composite images over a full year. Just try to reduce the period. Start with a short period and then increase if the image doesn't look good. So resolution will be 10 meters. This is the resolution of I will be using. So I predefine it. It's not used yet. It's just a variable. The collection is from Copernicus S1 GRD data, so it's a geo-referenced. Here I use start and end, so I defined it here. And polarization, remember I chose VH, so you could do VV as well. So just for simplicity, I'm just taking VH here. Here I'm computing the mean. Remember I have 2 months of Sentinel-1 data? Well, I'm computing the mean. That reduces the impact of speckle and anything that may have happened, like changes in moisture during that 2 months period. So I'm just averaging everything. Here I'm defining again a visualization variable that I will be using to display my image. I clip to the basin and I actually add my Sentinel-1 VH mean to the Landsat-8 data cube, and I just call it all images. So my data cube here, which includes Landsat-8 and Sentinel-1, is called all images. Now let's add ALOS PALSAR data. So ALOS PALSAR data is from mosaics that were created by JAXA, the Japanese Space Agency. So it's been processed, topography has been removed, and it is ready to use for science applications. So it's available at HV and HH polarizations, so it's 2 bands. So radar is not very complicated once it's ready for science use. It's just a set of bands, just like you have several bands for Landsat and Sentinel-2. So just consider them as bands, but they are sensitive to different things. HV particular to volume, and HH is also sensitive to volume, but also to the ground, and in particular it is used for looking at the impact of double bounce scattering. So double bounce on that happens in wetlands when you have a lot of water on the ground. So this is very interesting for wetland analysis. So if you have a wetland class in your region, you definitely want to use that HH band. But of course, that mosaic was created from data that's collected over the year. We don't know what the date is, so it will detect wetlands at a particular time. So hopefully that wetland was wet when the data was collected, but it is not a given. Otherwise, you can use the raw radar data and insert it in your Google Earth Engine code from the desktop, but you have to process it yourself. You can obtain you can obtain the ALOS PALSAR data from ASF, for example, the Alaska Satellite Facility, and process it yourself. So here I will be adding these bands to the all images classification. But first, what I'm doing is I am generating a new band. So we have two. We have HH and HV. I will be generating one that I will call HV-HH, which is basically the ratio of these two images, HH and HV. And I will rename that that band HV-HH. So I add this HV-HH band to the ALOS dataset. Okay. And here I am simply converting the digital number, DN, that is what the ALOS Pulsar mosaics are representing. So to convert them to dB, which is the typical way of analyzing the SAR data, radar data, that's in decibel, dB, you have to take the logarithm of that value, square, minus 83. Okay, so I'm just doing this. So HV now is represented in dB, and I rename that HV. Okay, now to display the ALOS Pulsar images, if they are in dB, typically if you go from -5 to -20, you will get most of the range of the radar backscatter. And again, I clip the data and I add that data to all images. And here I add Sentinel-2 data to all images, which I had not done earlier. So that all images now includes this Landsat-8, Sentinel-1, ALOS, and Sentinel-2 datasets. Okay, now I have my label. So what I talked about earlier, when you defined your classes using the tool here at the bottom, you had an attribute that you call class ID. So I will be looking at that. So now what we're doing is training the land cover classification tool. So the tool that I'm using here is the card classifier, so it's a decision tree approach. And what we're going to do is train that decision tree using a training data set with its label, class ID. So for example, red mangrove was 7. And the bands. Remember the bands, we named them earlier at the beginning here. So band 2, 3, and so on. And remember all the renaming that we did? We renamed them with these names. Okay, so these are the bands that will be used to train our land cover classifier. The region that we're sampling is defined by my GE classes, which are red mangroves, black mangroves, the mudflats, water, and so on. And the property is labeled, which is a class ID here. And we'll do it at a scale of 30 meters, which is Landsat resolution. Now we are training the classifier, which is called Smile Card. I think it's the new implementation. And this is our decision tree that will be applying to the selected bands. So the bands that you're using here for training have to be the same as the band that you use for classifying, of course. Otherwise it won't work. So that's why I had all the bands defined within a variable that I called bands. Okay, so here we train the model, and here we're applying the model. And the output is a classified land cover. So we have a new map of a land cover for our region. I haven't displayed it. I will just go through the model again. So here I have another variable that I call my palette, and I have red, black, blue, green, yellow, cyan, and some other color. I'm not sure. I think it's brown for my different classes. So I try to choose color that somewhat are different, so it's easy to see and somewhat representative of what the land cover is about. So red mangroves are red, black mangroves are black, water is blue typically. So and then I add my classified image into this bottom window here. So I will display that, and I will export that classified image to my Google Drive. So let's run the code. Okay, so it's centered on the point that I specified at the beginning. It displayed the Sentinel-2 data. I remember I only displayed Sentinel-2 in that code. I could have displayed ALOS PALSAR as well, or Sentinel-1 and 2, but I just displayed Sentinel-2. So now you see the classification being displayed. So this is our classified map add layer. So this is what's happening here with the palette that I defined. And you can see we did a pretty good job. Typically, if your interest is to get the best classification map possible, what you could do is run that classification again with new points. For example, so I think my mudflats are pretty good. My black mangroves, let's see, it's going to come up pretty soon, are pretty good. See, there seem to be some errors in my map, of course. And one of them would be, say, since I'm really interested in my mangroves, if you look at those, you will find errors, right? So what I recommend here is, so you have this green here. The algorithm has problems trying to differentiate between inland forest and black mangrove. So what I'm going to do, I'm going to go to my mangrove, black mangrove class. Okay, it's here from geometry. And I will add points that are classified as forests, just to force the algorithm to classify this as black mangroves. At one point, you won't be able to clean the image anymore because you will see that some of the inland forests will become mangroves. So the algorithm is unable to classify these. So just for fun, let's run this again and see what happens to this area if we did better. Well, you see that some of the points, like this one, was classified as black mangroves, but it didn't affect what was around it. So at the end, your data that you exported to your Google Drive is here. So in the task label, you can just run. You can give it a name. Let's call that number 1. Scale is 30 meters. You want it to be saved to your drive. If you have defined a drive like I did, I called it GE. And the file name will be, let's call it number 1 as well. And you just run. And you will see that little wheel here turning. And the classification map will be saved on your drive. And you can access it from your Google account.